Okay, so hello everyone. In this video, we will be solving the question number 3336, which is marked hard, but I'll definitely make it easy for you guys so that you can understand this question, get to the approach, and not only that, but if a similar question appears in the future, you can think about it and move to a particular or similar approach so that you can get the desired output. Okay. So let's first understand the question, what it says about, what are its requirements, and later we will move to the logic building. Okay, so we are given an integer array nums. Okay, your task is to find the number of pairs of non-empty subsequences. Okay, subsequences is the one of the main thing. Sequence 1, sequence 2 of nums that satisfy the following conditions. So we will move to the conditions. The subsequence sequence 1, sequence 2 are disjoint, meaning no index of nums1 is common between them, and the GCD of elements of sequence 1 is equal to the GCD of elements of sequence 2. Okay, so let's first understand what the question is about. Let's first see what is a subsequence. Okay, suppose we are given 1, 2, 3, 4, 5, and we need to find a subsequence. So subsequence is an part of a original array which contains all its elements but does not alter the order. We can skip few elements but we can't alter the order. So here is one of the example of subsequence. 1, we will skip 2, we will take 3, and we will skip 4 and we will take 5. This is a valid subsequence. Original order of the elements taken is preserved and we have skipped few elements. It is not compulsory to skip few elements, but if required we can skip few elements. This is a valid, but for 1, 5, 3, this is invalid because the original order of occurrence is disturbed. The 5 was after 3 in the original array, but we have not maintained that order. Okay, so we have understood what is a subsequence. Now, what does this condition mean to say? This one. Let's move on to that one. Okay. We will take the same example only so that all the conditions are understood and well fitted. 1, 2, 3, 4, 5. Will form to subsequence. Subsequence 1. Let's take 1, 3, 5. Subsequence 2. 4 and 5. As we can see that both the subsequence are valid as original order is maintained, but what is the thing which does not satisfy the equation is that condition is that phi is present in both the subsequence. As you can see that this one phi at index 4 is part of both the subsequence, and here it is said that no index of nums is common between them. If there was one more phi, we can once think that here it was this phi was this and this phi was this one. So it might would have been valid. But since this is not the case, so they are not disjoint. Okay, we have understood this condition as well. Now, okay, now let's move to the next condition, which is the GCD one. Okay, so what does this? Let's take same example once again. 1, 2, 3, 4, 5. Subsec 1. As of now, we will take 1, 2, 4, and subsec 2, which is 3 and 5. Let's check first condition. Are they subsequence? Yep, they are subsequence. The original order is maintained, and only the elements of the original array are part of this. And the second condition, that no two index are part of the same subsequence. Okay, so now let's move to the final condition, which is the GCD one. So what is GCD? GCD is nothing but HCF in just good term, professional terms, or more computational terms, or mathematical terms, whatever one wants to say. So, what is the GCD of subsequence 1, which is nothing but HCF of 1, 2, and 4? We can say that it will be 1. GCD of subsec 2 is HCF of 3 and 5, which is 1. I guess I'm hoping that everyone knows HCF. HCF is just the biggest possible number which can divide all the numbers taken into the computation. Here 1 divides all the possible numbers, and here 1 divides all the provided numbers. If subsec 1 was just 2 and subsec 2 was just 4, would this satisfy the given equation? Let's see. Its HCF would be 2, and here's HCF would be 4, which are not equal. So we cannot consider this subsequence pair to be a part of our answer. But here, since both the GCDs are equal, we can consider both of them into the answer. Okay, so since we have understand the conditions, now let's move to another logic. Let's first rub this. Hopefully the image is not moved. Okay, let it be. So now, as we have understood what the subsequences are, what are the conditions, now we have found one thing, that the main thing revolves around subsequence formation. Main thing revolves around subsequence. Just a second. Formation and GCD computation. The other all parts can be optimized later, but these two steps are the most important steps. So let's um, move to how we will do this. Let's take one at a time. We need to form subsequence, and we know that in subsequence there are two options for forming subsequence. We have two options for a particular element at a particular index, that we will take that index, or we will skip that index, because in it's our choice. In subsequence, we can form a subsequence like 4, or just a 4, 2 and 5. We have skipped 1, we have skipped 3, we have skipped 4. In the above case, we have skipped 1, we have skipped 2, we have skipped 3, we have skipped 5. So we can take an index, we can skip an index, but we just need to maintain the relative order. That is move in one direction. If we take one element, we cannot come back to take another element. Okay, so we have now found that we will how we can form one subsequence. But if we take this into the consideration and we try to find form two subsequence, okay, so in subsequence one formation, I have found one subsequence 1 and 3, but how we should make another subsequence such that not a subsequence 2 does not contain any index which are included in subsequence 1. So we have only three options, three elements to consider over here, which are either 2, either 4, either 5. So I guess let's move like to another approach. Like we don't want to form the subsequence one after another, but we will form two subsequence together. So here is the same test case. We will move with the same test case throughout the video. Okay. So for one, I have three options that I'll take it in sequence 1, I'll take it in sequence 2, or I don't want to consider it in any of the subsequence. So skip. If we consider sequence 1, it cannot be a part of sequence 2 as we have included it in sequence 1. If we take it in sequence 2, it cannot be a part of sequence 1. And if we want to skip it, we can skip it. It will not be a part of any of the subsequence. Okay. If after we have taken one, just okay. From each decision we have made, we have okay. How do you do this? Let it be. Okay. Uh, we have another option from here. From this option chosen, we will have three options. Likewise for skip, and from this option we have three options. So you can consider think like we have three options for each three options for each element. That is either take it in sequence 1, take it in sequence 2, or skip it. Okay, just for the thing, ignore the background music. Not music, background noise. So for each element, we have three options, which is take in sequence 1. If we take it in sequence 1, it will not be considered in sequence 2. If we take it in sequence 2, it will not be taken into consideration for sequence 1, and taken either skip it. So as a result, no one index can be part of both the subsequence. Okay, so that's also we have done. Now the step 2, which is the GCD computation. So why don't we calculate GCD when we are forming the subsequence? As a result, we do not need to explicitly make one other loop or another function or spare more time to compute the GCD of that subsequence by iterating its elements. So let's just build a rough idea or one approach at what we can do, because we can also think like At each step we have three options. Here we can see that. Let's change color so that it becomes interesting. At each step we have three options, and at each three children steps we have three more options. If we were to do it in for loop, we will need a while loop, but rather until this thing is done. But how we will maintain the while loop? If I have moved, like proceeded with this path, but if I want to come back again to this part and then go to this path, sequence 2, and after that I want to go to this path and then move towards this path. So in a while loop, I would not be able to do that thing. So which data structure would be most suited for it? Stack. Stack would be most preferable because as we move from one to take into sequence one, it will make a stack. And once this entire all the three children node operation is done, the stack will come. The stack pointer will point back here and to the line of code after this. After the stack pointer comes back to this line of code will be executed. So now we have these two options available. So as a result, stack will be a more preferable option, and we can move through all three approaches. Let's skip or take it in sequence 1 or take it in sequence 2. Okay, let's just first implement, and if required we can optimize it as well. As you can see, these are the reoccurring problems, and for reoccurring problems we have one approach which optimizes the solution and reduces the time taken by severity. Okay. Hmm. Yep, now my video is loaded. Okay, if you guys are not able to see the fonts properly, do let me know. Okay, and since we are using stack, you might have guessed the approach that it might be recursion. If not, no worries. After this question you would be able to. When forming a recursion, when you are not sure that what it should return, don't worry, don't write. Even I use this approach that initially don't write what is your return type. First make one function. Here we will call our function helper, and at each, what is this helper function doing? That at each particular index, at, at this index we are taking three options. Just it is doing just this much. Helper will help us to just perform three actions at each what you can say index of this array. So what we need is integer I, and at each step what are we doing? That we can consider it in either sequence 1 or in sequence 2. Don't worry about the data type, I'll tell you later. And what is the most important thing? If we have index, we also want the element, right? So what is it provided? You take this element, array. Okay. As of now, don't worry anything about the integer type. I'll explain what we are guys are doing, what we'll be doing. If okay, first option, consider it in sequence 1. Okay, we will consider it in sequence 1. and move forward. But how we will consider it? Why someone will be thinking that we should form the subsequence, but I think we should not form the subsequence because we need to find the GCD. What we will do is, okay, I have taken 1. So my GCD here currently would be 1. And here we have this many options 2, 3, 4, 5. And we are at 2. Okay. Now at 2, we decided that we should consider it in sequence 1. So instead of making sequence 1 like 1 comma 2, why don't we store it at GCD along the way so that when we reach the final node, we can just compare the GCDs of both the subsequence. Okay, suppose now subsequence 1 is 1 2, and now we have option for 3. Now we've decided that we will push 3 to subsequence 2. So we will find its GCD. So it's 3 for subsequence 2 and 1 for subsequence 1. Now, over the time, we decided that we will not consider 4 and 5. We will skip it. And we have reached the end of error. So now what will we do is check whether 1 and 3 are equal. No, they are not equal. So we cannot count this pair of subsequence. If here it was 1 and 2, and here we have decided to skip 3 and we consider 4. Okay, and then later we consider 5. So along the way we found out that the GCD of this was 1 and the GCD of this is also 1. So these are equal, so we can consider this pair of sequence, and we do not want the pair of sequence, we just want the count of the numbers of pair of subsequence. So storing a subsequence would be inefficient use of memory, but rather storing GCD along the way would be a better idea. So here now we have got that it should be integer. Okay. So we have considered this index into sequence 1. So we do not want to store the subsequence, but rather consider GCDs as we move along the path. So we will calculate the GCD. What is the current GCD? Current GCD is sequence 1. We will find its HCF with the nums element at this index. Okay, we have updated the subsequence 1 and we have not made any change in subsequence 2. So subsequence 2 will remain as it is and we will pass the nums area. Second option, consider it in sequence 2. Instead of it, we should use nums. Okay, so we'll again call the helper function after the stack has returned from this operation. We will get to here. So subsequence 1 will remain as it is. GCD will be updated. It is sequence 2 and this nums I and nums. For the final option, we have skip. It is either consider it in sequence 1 nor sequence 2. So we will move forward without considering it in sequence 1 now in sequence 2 and pass the nums. Okay, so what to do now? After we have made decisions after what to take and what to not take over this, we have reached the end of the array. Now we will check. Okay, when will be the end of array? When I equals to nums dot size. Okay, reach the end of array. Now what we will do is, first we will need to make sure that the GCDs are not zero, because what if both the GCDs are empty, and here we are given that non-empty subsequences. So empty subsequences will be having zero. So first we need to make sure that non-zeros GCD, if sequence 1 greater than 0 and sequence 2 greater than 0. Okay, if this is true, it will move forward. Now what will be check is that final thing, sequence 1 equals to sequence 2. So if sequence 1 equals to sequence 2, we can say that we have found one pair and we will return 1. Since we are returning 1, we know that now the return type is integer, and if any, either from here or from here, the condition breaks, we will return simply 0. So okay, this is the base condition. We need to consider from here as well, right? So since these are returning something, we will store it and give a valid integer variable name. Uh, take in 1. Okay, int take in 2. Okay, int skip. Okay, sorry. Now we will return all the possible values, all the possible pairs we have found from all three operations. So return take in 1 plus take in 2 plus skip. Okay. Uh, Over the time we found what should be the return type, how we will be considering the GCDs, how we will be calculating it, and how we will be returning. And in the base case, we have two requirements, conditions which are asked over here. That GCDs of every element, each subsequence should be equal and should be non-empty. Non-empty. Okay, but now we need to call the helper function. So since this is an integer return something, we can directly return it as well. Return helper. We will start from index 0. We will keep the GCD 0 also in the starting, and we are passing nums error as well. Okay, let's see. There are rare chances that my code compile in the first time, so bear it. You might have seen in the first two videos as well. Okay, okay. We have found that the test cases are passing, but the most important thing is this. Since the answer may be very large, it may we need to return it to 10 power 9 plus 7. Now, why it is said so? We can also find that suppose the length of the array is 200 and each of its elements are 200. Okay, so as a result, no, that's not the case. Okay, my bad. Sorry. So if all its elements are 200 and the length is also 200, so just imagine how many number of what you can say subsequence can be formed. With one, there will be two more than 200. That will be, I don't know. It should be NCR and that combination permutation we need to add. As a result, it will surely uh, exceed this limit. So we need to return the answer in the modulo 10 power 9 plus 7. Okay, so let's do that as well. We will just declare it as a variable here now. 1 e 9. 1 e 9 is 10 power 9 and then we will add 7. Okay, so but where to add? Here. Modulo mod. But what can happen is that during the addition of three uh, these three variables, it can during this addition only it will overflow. So before the modulo, even though we have added modulo, it will still be as overflow error. I am not able to recall what we said at as of now. So what we do is we write 0 long plus. So all the addition that happens is within the range of long and then after it we do the modular, and after you make any changes you should first try to run it before submitting. Also for the first timers it will give TLE, I know, but we need to understand each and every approach that we are using. So what is happening is that at each at each point we have three options that we should consider it in sequence 1, in sequence 2, or skip it. As a result, what happens is that each element at each node there are three options. So as a result it becomes exponential. How I can explain is that here are three, here three, and further three. So as a result, it grows in the powers of three. So as a result, this complexity without optimization becomes 3 power n. 3 power n is a huge number, as just you can see that 3 power 200 is beyond 10 power 8. I'll explain about time complexity. 10 power 8 nearly equals 1 second, and this is generally the maximum allowed time. So as a result, 3 power 200 is greater than 10 power 8. As a result, it will go beyond the allowed time and we hit the time limit. So now comes the best optimization, as we have discussed. At each at each node we have three options, and the same three options will be available here as well and here as well. So as a result overlapping problems occur. So and to avoid or to optimize overlapping problems, we have one approach called dynamic programming. So what it does is stores the results computed before, so that it does not need to be computed again and again. So we will just use the most basic DP over here, and I'll explain how to form DP and it works with each operation of recursion. So when you are forming a DP, dynamic programming, forming DP from recursion, you just need to make sure that you take into considerations those variables which are changing. So we know that in this recursion only three variables are changing. It is index, GCD of sequence 1, GCD of sequence 2. So we just need to make a 3D DP array. What we do is just take into considerations those variables which are changing and create a DP according to it. So as we know that three variables are changing, I, sequence 1, sequence 2. So a 3D DP would be formed. So a most basic would be to form a 3D vector. Okay, but my bad. But for what? Like 3D DP of what dimensions? So we can find that we just need three dimensions. For one is for integer, one is for type only, one is for in I index, second is for sequence 1 which is GCD, and sequence 2 which is also GCD. And suppose that all the elements of the area 200, then we can say that the maximum GCD which can be formed is 200. So maximum values of sequence 1 will be 200, and likewise of sequence 2 will also be 200. So why don't we know that I will be the number of size of array. Sequence 1 will be 200 and sequence 2 will be also 200. So we can dynamically like a form and predefine vector, 3D vector. So let's define one vector. Everyone has own method of declaring vector. I do this because sometimes it leads to confusion for the closing brackets. Okay, vector of int. Now we are considering to store in the form of vector of integer, vector of sequence 1, and vector of sequence 2. So we will, here is the v. The first thing is I, and that would be the nums dot size because we want that many dimensions. Seconds will be sequence of 1, and we found out that the maximum possible values will be 200. But to get the 200 index, its size should be 201. If the size is 10, we can go maximum till 9 index. If the size is 201, we can go till 201 200th index. Vector, vector, int. If you guys have any doubt regarding STL, do let me know. I'll solve, like try to make videos about that as well. And we will initiate, sorry, what you say, instantiate whatever it is with -1. Why -1? Because GCD can never be negative, and we will GCD is always greater than 0. And if we store it as -1, we can say that that condition has never been reached. Okay. Now we'll all like add this in the function definition. Okay. Now what we will do is In when we use DP, we just need to add two lines. First is check if such problem or that occurred before. That is how p of I of sec1 sec2 not equal to minus 1. If that is encountered, we just return it so that we do not need to run that computations again. But what if it is not? We will just store it here, whatever we have found, and add those in the recursive calls as well. Okay, let's check. Okay, this is running. Okay, so our solution is accepted, and time complexity is okay. Okay. What should be the time complexity? If possible, if you guys know, do let me know in the comment section. But for the DP, the time complexity is generally n power number of changing variables. Here in this case, it will be n cube. What is the space complexity? Okay, you guys tell me about the space complexity. I'll tell about it in the next video. And this method, what we have used, is called top uh, top to bottom. Okay, I am not able to recall, but there are two more optimal methods which will be covered in the next videos. As of now, however you have found, do let me know. If you have any feedbacks, if you have any doubts, or if I have missed particular thing, do let me know. Okay, thank you.